This is paper ID IEEEIC58 orbit identification from scatterometer level 0 signal window images, a pattern based approach. I am Mudit Dolakia presenting this paper on behalf of my co-authors Anuja Sharma and Dr. C.K. Bains-Daria. Here is a presentation roadmap. We'll go through the introduction, then related work, then proposed work, then results, and we will conclude. In introduction, there is a scatterometer, data products, data quality evaluation, and the problem. Now let us go through a video which shows the rotation of this particular sensor around the earth, that is from North Pole to South Pole. It can be seen in the video very clearly. Now this sensor has been boarded with OceanSat-2 satellite. Some mission specifications and geometrical considerations for the user knowledge has been shown over here. Introduction to data product. Now what is data product? Imaging information and non-imaging information, if grouped together in a certain data format like HDF4, NetCDF, and H or LRPT, that is rate picture transmission format, then it becomes a data product which is used generally to pack the remotely sensed data. Now our sensor has a very advantageous feature, that is direct ambiguity removal, inner 4, inner aft, outer 4 and outer aft. We have total 4 measurements for a single point, that is beneficial. Now what is data quality evaluation? As we can see in the diagram, that from Shadnagar the receiver packs the data into certain formats at different levels. Now raw data consists of certain sensor parameters, as well as level 1 consists of some ephemerized and at altitude informations like longitude, latitude. More information can be found in certain references shown in the bibliography. Now data quality evaluation software evaluates the data and generates the alarms as well as report for a certain data products. Considering such kind of digital geometry, the problem was found that at level 0 we have certain orbits consist in a single product, whereas in level 1 we have a separate orbit data. Now for a DQH system, it is really a huge requirement to get a retrospective analytical standard, that is bridging the gap between level 0 and the level 1. Now to come up with certain problem, there is a technique which has a mathematical background, that whenever the receiver is detected at the Svalbard, it again starts the opposite behavior of latitude reading, that is if it is in increasing manner then it starts decreasing, and vice versa, that is if it is in decreasing then it again starts increasing. The degrees of longitude and meridians of longitude latitude have been shown. Some related work also describes such kind of problems, but there are no certain meaningful standards established yet. So we have proposed this particular approach, that is pattern based orbit identification from synthetic aperture radar images, which is to identify the black sharp in our case. But the condition is the scanning considerations for our images have been defined for the simplicity of action. This is the proposed approach, where HHN VV images have been shown. These are the scaled version, but if we window a certain portion and show the original image, then it shows these kind of 4 images. Now interesting point of these images is that it contains a single black sharp. It is exactly the orbit changing point. Now the implementation wise detail have been shown, that using this particular black sharp, an algorithm can be proposed to identify this black sharp which can consider a scanned image in terms of predefined pixels and number of scans, and also can identify the number of orbits from it. The asymptotic time complexity is O of m n, that is m is number of scans and n is number of pixels per scan. The algorithm can be visible. This algorithm can be implemented using a normal C program. We have tested it over several NRSC raw data. The efficiency as well as accuracy is good in terms of analytical standards. We have not compared it in terms of statistical standards. Algorithm complexity is big O of mn as discussed earlier. Now this is a very raw approach but very useful, as it also bins and neglects the false orbit points. That means the orbit points which are lying on a certain orbits lies on that particular orbit only. It won't get distinguished in different orbits, and a very smooth approach can be derived through normal C program. And we conclude that this is a very useful approach for a DQE team as well as the application specific user, as using such predefined geometrical considered images and a C language, this approach can be easily implemented. Here are some references through which we have been motivated for approach as well as the implementation, and that's it. Thank you.